Okay, so we're looking at chapter 2.1, example 3, which is write the answer in scientific notation. So we use scientific notation when we have really big numbers or really small numbers. This actually has a lot of practical applications in things like astronomy, physics, biology, because if you're talking about cells, really tiny things like that. So scientific notation is actually pretty useful. In general, it's set up that it's c times 10 to the n. This is a times sign, not an x. Your c is a number between 1 and 10. More specifically, it can be equal to 1, so c is greater than or equal to 1, but it has to be less than 10. So how you're going to do these, the reason they're in this section is because really you're applying the product rule for exponents. You can rearrange these. You can make this 1.2 times 6.7 times 10 to the negative 3 times 10 to the negative 7. So I just rearranged my decimal numbers and then my tens. 1.2 times 6.7, if you put that in your calculator, you'll get 8.04. And then this would be times 10 to the negative 3 plus negative 7, which is 8.04 times 10 to the negative 10. Here you're allowed to leave negative exponents. That's not an issue. You really just need to make sure that this number right here is between 1 and 10. In this case, it is. So your final answer is just 8.04 times 10 to the negative 10. Part B, this is a division, so now we're going to subtract our powers, but you can still kind of group this up. You can think of this as 1.1 over 5.5 times 10 to the negative third over 10 to the negative 8. 1.1 divided by 5.5 is 0.2, and then this would be times 10 to the negative 3 minus negative 8. So you have 0.2 times 10 to the fifth. Now the issue here is this number is not greater than 1. It's not even equal to 1. So we need to move the decimal over. We need to move it over 1 time. So we need to make this 2.0. That means that our power on our 10 has less work to do because all the power on 10 does is it moves your decimal to the right or to the left. Since we needed to move our decimal to the right, that means we're going to decrease our exponent. So I have times 10 to the fourth. I want to add one example because I want to show you the other way. So go ahead and add a part C, and we'll make this 3.2 times 10 to the second, and then 5.1 times 10 to the third. So again, you can regroup this. You can make this 3.2 times 5.1 times 10 to the second times 10 to the third. 3.2 times 5.1 is 16.32 times 10 to the fifth. Now notice my number is bigger than 10, so I want to move my decimal over once here. So now my power on my 10 needs to do more work because it has to move the decimal one more time. So it becomes 1.632 times 10 to the sixth. Now my number is between 1 and 10. So to summarize here, the rule is that if you have to move the decimal to the right, you're going to decrease your exponent. If you have to move it to the left, you're going to increase your exponent. I will be honest with you, I am so bad at remembering which way this goes. So the check that I always do and that you can always do as well is that you just type both of these into your calculator. Your calculator will spit it out as a decimal. It won't put it in scientific notation. And then you just compare to make sure that you went the right way. They should be the same. If they're not the same, then you went the wrong way with your decimal.